Hello, it's Keith here, and this is day 4 of my Grime Z80 multi-platform programming project. Now, if you've been following the series, you'll know, but if you haven't, then I'll tell you a little bit about it. I'm currently trying to remake the DOS game Grime in a way that I can compile it onto 11 different systems. And you can see the current state of the game. It's in pause mode here, but you can see it on a variety of the different systems. So we've got the Enterprise 128 version here. We've got the Sam Coupe here. We've got the MSX here. We've got the TIE 83 here with its tiny little sprites, but it does work. We've got the Game Boy Color here, and we've got the ZX Spectrum here, but it does work on all the systems. I just got a few of them on screen to show you, and I've got them paused so that the computer doesn't run full power and heat the room crazy, because I've had to turn the aircon off, which is not good at this time of year in Japan. So let's have a quick look at one of the versions here. Now the functionality is of course identical on all the versions. So we've now got a little bit of sound. So whenever you shoot something, it makes a little noise. And you can see that now the enemies are seeking the player, which I think they were yesterday. However, now the player is in peril because you can actually die. So we've got proper collision detection in all cases, and you can see I've just died, and it says you're dead because you suck. So the computer is not impressed with my playing. So you can see that was that version, but the game does play the same on all versions here. So if I just unpause this version, I can remember the controls. That's my current challenge. I'm dead, so that didn't go very well. Let's try this version. So you can see, I mean, the game, it's the same game code. The logic code is all identical. It's just the graphic and keyboard code. And as I've said before, the things like the keyboard code are based on the code from my tutorials. So if you've been following, then you've seen it before, and it's not anything special I've written for this series, which is why I've been able to get this game to this sort of standard of playability in just really 4 days. So I think I'm quite something between impressed and relieved about how well it's been going, because I've come across no major problems, only very, very slight bugs in the base code I've been using, and no major bugs in the Grime game, because, you know, as I say, with 4 days to go, well, a serious bug could take 4 days to find and debug anyway. So it's been going very well. But anyway, you can see the game is working on all of these systems here. So let's just close these down. And let's have a look at the actual code, and I'll just go through some of the changes that have happened. Well, what has been changed? Well, the first thing you may have noticed is we now have a score, and we also have a life counter, but the life counter doesn't currently work. So the first thing I've had to do is I've had to define some new code for the score position. It's using 4 binary coded decimal bytes, so 8 digits, and the binary coded decimal handling code I copied directly off my tutorials, the advanced lesson 1 I believe it was. So that was another thing that I was able to pull in from the tutorials and get working in minutes. What if I'd been writing completely from scratch could have taken quite a lot of time. So there we go, that was another use of the tutorial code there. So you can see we've also got this new allow fast growth function. This is when the player, when the invaders, which I'm calling the purple things that come in from the side, I'll just show you those. So I've got these new 2 enemies. These are the invaders that come from the left-hand side, and they drop new spores, and the descenders drop onto the player, and they should invert the Grime, changing its shape, but that's not been coded in yet. So the invaders will fly in and drop the spores, but the spores, if the game isn't very active, will initially grow very fast, and this allow fast growth is a sort of counter to check if the spores should grow very fast or not. And the way this is decided is, well, has the player actually shot anything recently? If the player's not shot anything recently, maybe they've killed all the Grime, so we need to bring the new Grime in and give it a good chance to grow in so that the player has more of a challenge. So that's what that is. Nothing shot is related to that. That's the amount of time since the player last shot at something. If the player is slacking off, then we need to give them more things to do. Fast growth is again related to that. The allow fast growth enables this, and the fast growth is a counter, and while the fast growth is greater than 0, all of the ticks evolve the mold, whereas most of the time most of the ticks will not. So that's what that is. Random seed is to do with my new random number generation, because we've got events happening randomly, like the invaders coming in the screen now. We've got a random seeding program, so that was something that's had to be added as well. So let's have a look at some of this. So we're starting the random seed off by loading A with R. Now, as usual, this is another thing that the Game Boy can't do. So as I've usually done, I always use the R register as a random number generator. So what I've actually done is I've XOR'd all of the registers together and then loaded that into this fake register of R. And it's not going to work great, but using R as a random number generator never does. So I considered that acceptable for now. And one of the things on my to-do list is to create a title screen, and what I'm going to do is the title screen is going to have a press fire to start kind of thing. The amount of time that the player doesn't press fire to start will be counted up, and that will be used as the initial random seed, which will improve the random number generation a lot. So that's going to get around the whole problem. Just some generic code here. This is my my function to show the current lives and the current score. They don't work on the tie because the tie screen is so small, and I don't have a 4-pixel font, so it's not really possible. Then we use this getRandom function, which is a new function, and it gets a number between 0 and 255. And then we do some functions here, and we decide if we're going to create an invader or a descender. The descenders are the ones that drop down, the invaders are the ones that fly across and drop the spores. Next, we load in the fast growth. If there is fast growth, then we always do an evolve. If there isn't, then we use the normal game logic to decide whether to evolve the grime, move the seekers, or do nothing and just pause. That's all pretty straightforward. Now, if nothing's been shot and the count has reached 64, then we automatically spawn 2 invaders and a descender. Now, I've already worked out a kind of secret to this. If you shoot either one of the invaders or the descender, then the game will no longer be active, so the mode will not enter that fast growth stage. So that's it's a little trick at the moment. I don't know whether that's a good thing or a bad one, but as I say, it's something I have noticed is a way to stop that from causing you trouble. Here's the code to create the descenders and the invaders. Now, we're using the random number generation to get a column and a row. If we're doing a descender, then it just needs to be on the top line, and so we just select a value from 0 to the width of the screen, which is either 32 or 20 on some of the systems. If we're doing a invader, it has to come in from the left hand side of the screen, so that's screen width -1. But then we need to move down, we need to multiply the random number by 32 to get the correct row, and that's what all of this code here does. It could be more efficient, but it's good enough. If the player is dead, we show the message on screen. This needs to be improved. It's not good enough yet, but it's just a test, and at the moment the game just halts when you die. So as I say, lots to do there. Now, I don't think we had the bullet collision detection working yesterday even, and that's here. So if the player hits something, then we make a sound here. We clear the current tile. We update the random number generator, which is that's to add some randomness depending on when the player is hitting things too, so to keep things good and random. The binary coded decimal values have to be the same length as the score, so I've got those stored down the bottom, and so this is the binary coded decimal value of 1, 3 and 5 for the different kinds of enemy. You should be able to shoot the invaders and evaders and descenders and get even more score, but that's not been done yet. I think I've overlooked something actually, just a moment. So yes, this is the player. This is to detect if the player's been killed. Now the player is decided to be dead if all 4 sides are surrounded by enemies, or the player is on an edge or in a corner, so it's impossible, so they've surrounded themselves on one of those sides. Now these far left, far right, far top, far bottom, this is checking if the player is on the edge of one of the screens, and if they're not, then it checks if they are still declared alive by that direction, if that makes sense. So if the player's on the far left, we jump here, but if we don't, then we move the scanning memory address 1 to the left, read in, see if it's less than 8, which means it's a bullet or a player sprite. If it's not greater than 8, they are surrounded on that side. Now what we do is if we find they are okay, we jump straight down to this, which means that, well, we can carry on with the normal processing, but if we get to here, all of the checks have been done and we've not found any reason they should be alive yet, which means by definition they're dead. So that's how we're dealing with detecting the player has died at the moment. We do need to add another player death detection, which is if the invader or the descender hit the player dies by default. That's not been coded in yet, and it won't be handled by that routine. It'll be handled by the movement routine of the invader and descender, which we'll have a look at now. So here's the code that handles the new two kinds of enemy. The descender falls from the top of the screen, so we check to see if the descender has reached the bottom of the screen, and we remove it if we have. If we haven't, then what we do is we read in the current value of the object we're moving, which is obviously the descender. Then we move down a line, we read that in, and we swap it. So this will actually have the effect of moving the mold up one line as the descender falls. Now that's arguably not ideal, but as I've already said, the descender actually is designed to modify what's under it, and I thought it was a good trade-off. I didn't want to have extra buffers to store backups of what the descender had previously had under it. I didn't think it would make any real negative effect to the game, so that's just a little shortcut. So rather than backing things up and restoring them, I'm just actually swapping things along, and so that's what that code there does. The invader does the same, but it has this blob dropping function. This is based on random numbers here, and depending on the screen size, if the screen's small we have to increase the frequency it drops blobs, because otherwise if the screen's half the size the chance of it ever dropping a blob is half the amount, and we need it to drop blobs when the game starts and when the player's slacking off. So we do that. If we get here, then we read in the fast growth parameter, and then we store it to the fast growth counter, and this has the effect of if we're allowing fast growth, then the fast growth counter is reset, and then there will be an instance of fast growth. We load in the value 8, which is the sprite number of the starting blobs, and then we carry on with the processing. So at this point we're just restoring the pixel, the block that the invader has just left, and that will either be blank or whatever was under the invader before, or it will be the new blob, and so that's the end of that. So this is the previous code that's not really changed, and so all this is the same. So the palettes are getting bigger, and the Game Boy palette is now actually over 16 palette definitions, and I just had to make a small change for that. So you can see here we're now using 32 palette definitions on the Game Boy and 16 palette definitions on all of the systems. But the palette code does work with that, that's no problem. Now you'll notice that today my sprites still aren't very good. They look pretty good on the 16 colour systems, but on the 4 colour systems and on the TIE, the colours are all messed up, and to be honest I'm not going to worry about that at the moment, because obviously the game isn't finished. There's other things that I need to put more priority into. So I'm thinking of doing the sprites properly on the other systems on the last day, because at that point I'll know that I've got some leeway to work with, and I can make sure that I'm not doing work twice, because I do make the sprites look really good today, but then add more sprites tomorrow, and then have to remake the sprites look good again. Because one of the things I'm thinking of doing, if I have the chance, is adding animation, so there'll be a second version of all these sprites with some slight movement differences, and then toggling between them, alternate frames or something, just to give a little bit of movement to the game. But obviously things like that will need to be done twice, once for the 16 colour and once for the 4 colour, and probably other times for the 2 colour systems, and maybe another time for the TIE. So again, I don't want to put time into doing graphics at the moment, when that work can be done at any time and could change at any time if I actually add or alter the sprites. But there we go. That's the current state of the game as it is today. I think a fair amount of progress has been made today. There's obviously quite a bit more to do. What have I got to do? Well, I've got a little list here. Let's have a look at it. So I want to make a title screen that just says the name of the game and a few credits thanking my patrons and things. We're going to have a high score on that title screen so that the player has an incentive to play again. The life counter does not work at the moment. It says 0 and it keeps playing indefinitely. You will have 3 lives in the proper game. There's going to be a game over animation. I don't know if you remember the Grime game on DOS, but when you died there was this kind of descending mould that appeared on the screen, so I thought that was quite fun, and I had to at least try and match that, so that's what we're going to do. We're going to create that mould effect. Then we need, I want to do some sprite animation, so as I said I'm going to have a second bank of tiles, and so we'll toggle between them to have the Grime kind of wobbling a little bit, which will be quite fun. The invaders don't currently kill the player. They should. The player should get score for killing the invaders. We need to improve the sprites, as I just said, on the non-16 color systems. The sound is working, however, the sounds are quite variable on the different systems, and on the Spectrum, because I'm using the internal beeper, which basically uses all the CPU power. I need to tweak it and just make sure everything's nice. And also I've only got a sound effect for shooting at the moment, and coincidentally, because I don't turn that shooting sound effect off, when you die it makes a loud rumble, which sounds great, but it's actually not an intended effect. It's almost a bug. The speed differs quite wildly on the different systems. The systems that have got hardware graphics like the Game Boy with a small screen are very fast, but systems with software graphics like the Sam Coupe with a very big screen are much slower. So I need to, there's a delay in the game still, so I need to balance that out to make them all fast enough. And then if you press Fire 3, it will toggle the control method, but at the moment I'm not doing any kind of pause when I've detected that, and last time I used it, it was almost impossible to control, because you would you'd press the toggle button and the system would detect it twice because it wasn't waiting for you to release the key. So that's obviously a pretty major glitch with regards to playability on the systems with only one fire button. So all of those need fixing, but loads of time left to do it. Game's going pretty well. I'm not aware of any bugs in any of the systems that are showstoppers that render the game unplayable. So I think everything's really on track, and hopefully tomorrow it's going to look even better than it did today. I hope you're enjoying this series. Please follow my channel if you want to see more. Thanks for watching, and goodbye.